Thank you for joining us.
No me llena. Alors, už m'assois.
Excuse, sorry for that. Hi everyone. Now we're going to talk about bionics, prosthetics, and how do we make them, use them, make them better, and connect them ultimately to the human brain with three experts. We have with us a student, David, who built himself his own arm out of Lego. We're going to explain this in a while. That's quite amazing, you'll see. But the other people are amazing too. We have Ernesto Martinez Villalpando, head of Wearable Technology System for KOPIN Corporation, who is an expert who studied a lot in prosthetics, and we'll explain him how do you interface this. And then we have Moran, which is a specialist and researcher in brain interface, and how do we one day will use our brain to order to these enhancements that we are able to make. But first of all, we're going to start with David Aguilar. Hi, David.
Hi,
Thanks for joining us. I mean, I've been with you for a couple of hours in the show, and people are amazed, and it's truly amazing what you've done. So the arms you have one here, the other one is there,
Yeah.
and you built them yourself as a kid. You're a student now. You will go to the university next year to study in bioengineering. And first of all, for everyone to see this incredible stuff that you built yourself, I think we can have a small video to show that, and I'll ask you a few questions after that. Can we launch the video? Let's go.
I built cars, planes, motorbikes. But now, I built an arm.
Meet David Aguilar.
My name is David Aguilar. I am from Andorra and I'm 18 years old.
When David was born, his right arm hadn't fully developed.
This is my right arm. Well, growing up, it was quite annoying because I received a lot of commentaries like, oh, you don't have a hand or something like that.
And while some would see this as a disadvantage, David is just a regular kid. He likes EDM. He goes by the name Hand Solo. Get it? He has an embarrassing dad. He goes to school.
This is my school.
And he can open doors with his Lego arm. So cool. Growing up, he was obsessed with Lego. So much so, he wanted to make it a part of him. Literally.
I built my first prosthetic arm when I was 9 years old, and I built it around my hand. It started being a boat.
Unfortunately, the Lego bricks weren't strong enough, and it wasn't for another 9 years till he would try again.
This is MK1. This is Lego Technique. It's like the sophisticated part of Lego. I can do push-ups with this thing, so it's quite strong. When I first built the arm and it was fully functional, I went to the mirror and I was like,
That model, the MK1, only took 5 days to build. Of course, like any good inventor, he got straight to work on an upgrade.
And this is MK2. It has a battery that works like a biceps, and it has this fishing cable that ties up in here. When I fix this to my shoulder, I can do this. And the arm closes. I can stop in the middle and move it by myself. When I first brought this, they're all really amazed because how can somebody create a hand out of Legos? I was a normal guy, and when I built the arm, everyone was like, "You're awesome, you're really smart." They told me they are really proud to be my friends. It's amazing.
Yeah. You deserve it. So, before starting doing this, you never had a normal prosthetics. The ones you made yourself were the first ones you have. Why didn't you want to have a prosthetic for a start?
Well, the first prosthetic I built, it started being a boat, and I put the boat inside my arm, and I thought, well, this could be something that can grab objects. And this, it's the one that you saw in the video. It's the smaller one. This one is bigger than the So the one that I built when I was 9, it was this long. The second one is longer, and the third one is like a normal arm. I wanted to be as more likely as a human arm.
Okay. And you didn't want a regular prosthetics out of the box like you could have had?
Well, now that I understand how brain signals and everything works, I think it could be very, very amazing to have a prosthetic that, for example, reacts to protect yourself when a ball comes to you, like a reflex act.
Okay.
So it's connected to your brain somehow. I don't know how, and it's more sophisticated than maybe the most of the prosthetics nowadays.
Okay, so we're going to talk about the future of these wearables and these things that might happen one day. We're going to start with Ernesto. You've been a researcher in prosthetics for years, especially in the MIT with the very biomechanical part of Hugh Herr. Can you tell us about where we are now on bionics and what we can do and what people are studying on?
Yeah, definitely. So I have a few slides presented so I can show you a little bit of the state of the art.
Let's go.
Okay, so my journey has taken me through the development of bionics, wearable, but in general, human augmentation. When I was younger, a little bit younger, I dreamed about this $6 million man, 1970 shows, but it's no longer think of sci-fi. It's a reality, and people now are living it, building it, and actually experimenting with their body to the extent that we're here celebrating the innovation and the technology of how to become better humans. So I worked under the mentoring of Professor Hugh Herr, if you've heard of him. He is one of the leading minds in bionics. My work took me through development of the first powered foot prosthesis, and eventually through the bionic knee, developing a general bionic leg that interfaces with the body. So this has been some of my early work. Beyond bionics, I decided to work on more technology that I was focused on exoskeletons, and my journey took me to Harvard and understand a little bit of how soft exoskeletons can help people with different disabilities engage and learn. Specifically, I work with children with cerebral palsy and development of their neurological pathways so that they can improve walking at an early stage as they develop. Some of this work is a little bit on the next video, so let's see, next one. Oh.
I don't know if you can, the next one is coming. You have to keep the... So these actually are pumps and air. It's soft robotics,
yeah, soft.
Which is kind of futuristic now. Nobody has them on stage.
And the latest of the work has taken me from soft exoskeleton to other ways of human augmentation. And my latest work has been on starting a new program on smart glasses. Think about Google Glass for sports, and it looks something like this.
So it's another way of augmentation, but with sport and with that, with glasses.
And essentially, this was the latest work I did with the Olympic team and USA Cycling. Unfortunately, Munir, the earlier speaker, couldn't make it, but he was actually working alongside with him, where we worked on this human augmentation technology through smart glasses to improve the performance of the Olympic team, giving them the advantage to medal at Rio and be the first-time winners.
But you're not going to give cyclists prosthetics. No.
No,
No
but
cyber
It's the
muscles
same
for the
idea,
moment.
same framework.
Okay.
Human augmentation from bionics, wearables. So-
When you hear about David's story, when you were a student in that field, would you imagine that people could be able to build their own devices, prosthetic devices? How do you react when you see such an inventor?
Well, it's amazing. I think the democratization of technologies has enabled people like David to access and hack their own bodies. In the past, technologies like this were very expensive to develop, right? And now with things like Legos or others, people are very innovative and they want to build this. 3D printing nowadays. So I'm amazed and I cannot wait to see what the future brings for David and for the rest of the people that want to augment their bodies.
David, you'll be part of this future because you're a student now and you're gonna start in this autumn studying bioengineering. What is the purpose of what do you want to do now as a study?
Well, when I finish my studies, I would like to investigate a little bit about how science has gone in 4 years, because science every day is going faster and faster, and we develop things that yesterday we thought we could never do. And I want to create an enterprise that helps people with disabilities like mine, or maybe with the legs, and in purpose to enhance their abilities as humans, and not only to correct the disability, but to improve them.
Okay, well, that's great. I would like to have the opinion of Moran about that. You are studying specialist of the brain and of interfaces, and you are working on the next step. For the moment, we've seen used like this, but it's controlled by your arm and by the moving of your arm. Everybody dreams of having such devices controlled by the brain. And when we worked about this station, you told me there are still 3 challenges in that. Could you tell us more about that?
Sure. So there's basically 3 different problems that stop us from having a prevalence of people having devices talk to their brain and move around and control them. And the challenges to everyone seem like they're mostly about actually building the arm and connecting to the brain, but that's the first barrier. Right now, neuroscientists like myself are pretty good in understanding the language of the brain. We know how the brain speaks. We know what part, the top of the brain, the motor cortex, is actually coding the movement. So we know how to read that. And effectively, we can read that and send a signal to a robotic arm that will move kind of like the one we see here. That's problem number 1. We're doing really good in solving this one. There's 2 above that. Problem number 2, and that's the harder one right now, is how do you get something inside the brain? So to actually read the brain activity, you have to put a device that reads from the inside of the brain. And right now, the best way we know to get inside the brain is to drill a hole and put a chip inside. And that's pretty invasive and not really something recommended, even though there are right now about 140,000 people in the world that walk with a chip inside their brain because we put it there to solve some medical problem, epilepsy, Parkinson, and so on. So we can get inside and solve the second problem, which is how do you read the signal by drilling in. But what Elon Musk and Brian Johnson and many of my colleagues are spending most of their time right now is finding ways to create a tool that will get things into the brain without you having to drill a hole, presumably by eating something that will build itself in the brain or injecting something into the brain.
Do you think that's feasible in a lifetime? In how many years do you think because the implants that are used for people with diseases like epilepsy or so have been existing for like 10 years, but they haven't improved much for the moment. So what do you think the second part, finding a non-invasive way of connecting the brain, will take?
So this ties to the third one, which I'm going to tell you in a second, the problem. So we are getting better and better in building those chips to get inside the brain. We didn't find a way to get it in that actually can get out also. So the problem that we have is not just getting it in, but we want to be able to also take it out if you want, or also if we want to upgrade something, or if we want to change something, or maybe if you have some infection, we want to be able to take it out, and that's what we didn't solve. So it's getting it in and also controlling it from the inside and doing things to change the batteries. That is still part of the second problem. But the main thing that stops us, and that's I think where everyone in the room can weigh in, is that we didn't really solve the idea of the ethics of that. So we said, okay, let's imagine that we know how to read the brain perfectly and control a robotic arm. Let's imagine we can actually put something inside the brain that we can take out and control entirely. The question still is, do we want that? Do you guys want to allow someone to put something in your brain? And do we as a group want to have people that actually have better brains than others? And what does it mean? What does it mean when someone has higher IQ just because they can think faster? What does it mean when someone can actually solve problems that you cannot solve because they have devices that add up to that? And that's something that we can all weigh in because that's another problem that we have to deal with right now.
What's your answer? Is it feasible? Should we do this? Some Elon Musk thinks we should, but he has the money. He can buy all the research he wants to make it feasible. But the regular guy on the streets, people, but they will probably not be able to pay for it.
So I think that I give you my opinion in a second, but importantly, I think here everyone should have their own opinion because it's a question that's moral, not a question that's scientific anymore. Do you want to have two classes of people, some that are smarter, some that are not? So I think yes, and I think that it's because if technology offers something, it usually gets used by someone. So it's better if we all use it, if it's open source and everyone have control, rather than if we say no, and then someone will do it without our control. So if you say yes and you make it accessible to everyone and you control it in the right way, at least we have the guards of that.
But the question, for example, Ernesto, you work with cyclists. You could enhance them by because they will have in the brain directly all the information they need to win the race, for example. They could be. Would it be fair? Would it be normal in the sports field?
Well, I think it's going to be a process of evolution like everything else. And what I mean by that is technologies, I think, go far beyond what regulations today can enable, right? And ethics and other decisions that have to be made. I mean, to the extent that chemical enhancements have been around for a long time and people use it regardless.
Well,
it's so, right?
They use it
now,
unless it's forbidden or until they get caught.
Is it fair or not fair?
Yeah.
That's up to people who regulate it. Technology, I think it's in many ways going to be in a similar way. When you start having public access to technology that allows everybody, and when I say everybody, that's another ethical question, right? Financially accessible, then I think you're going to start getting into age where humans, as a kind, will evolve to a next level, right? And I think today, and I can tell you that, right? In the past, you're wearing something that if you didn't have this, you were disabled.
Yeah, and I wouldn't be able to be on stage.
You're going to be working and that's that. But now, it's a fashion statement. So it enhances you. So when can we reach that point?
Yeah. With my glasses, I can read the question that people send using our application on the VivaTech app. And that's one very interesting that is targeted to David. And it links to what we said. When you initially decided to do this arm, was your idea to recreate a human-like arm or to make one that was more capable, but was better than a human arm?
I think that it's very difficult to improve the human arm with Lego, but I think if someone gives the materials to build a more sophisticated arm, I think, well, if I have the studies, I could improve the capacity of the arm because when I decided to build this one and I was finishing it, the last part was the hand. And I decided to build a hand that has 5 fingers that close in one point. So the only mistake that I forgot about Legos is that bricks are very big and they aren't that strong to build thin layers of Lego in order to close fingers and grab objects, because this arm can grab heavy objects. The first one can grab light objects, and I think if this one had 5 fingers, it would be very difficult to be as useful as this is right now.
I've got another question for you. When does Han Solo intend to become Iron Man? I think it's because of Mark 1.
Yeah, in a video that's in internet on American TV that's called Right This Minute, they said about me that I was the Iron Man of Lego. And I thought, well, as the first one is red and yellow, I can call this the first one the MK1. So the second one, I can call it the MK2. And well, I'm now developing the third, and it's a tough work, but I think I will realize how to build it.
We saw in the video that it's also changed the way people look at you at school, for example.
When I first bring the MK1 to school, they were amazed by how a Lego could improve a disability, and they were smiling for the entire day because they saw me happy, and they saw a man that a man that improves himself with a toy.
Okay, great. So it's a very original and incredible way of enhancement. I've got questions probably for Moran about, do you think that headsets, normal headsets, could replace invasive brain surgery?
So generally, the farthest you go from the inside of the brain, the signal becomes less and less kind of specific. So it's harder to do more things, but it doesn't mean that we're not going to get better at that. And in many ways, I think that what it calls is changing our imagination. So right now, when you built this prosthetic arm, you kind of used the model of a human arm originally, but there's no need for that. We can think of what is not working about the human arm, like we cannot do some things, some movements, and maybe you can get a better one. So the head can give you some signals, like maybe up, down, left, right, but you can then use them in prosthetic arms to build a much more sophisticated thing, like maybe an arm that just puts a light bulb in one move. Instead of just having to do it in many, many twists, you can just press play and it just does that. So all of those movements, we're limited right now by what biology gave us, but there's no need for that. So if we put headsets outside and we read the signal, we can actually do much more impressive things than what we got from nature.
Well,
Ernesto, you wanted to react?
Well, I actually wanted to say about something that David just mentioned on the way that people were perceiving him when he came to school. And I think that really strikes me, right? Because we talk about technology and access. So first question for David is, do you think yourself as disabled? I mean, I know this is a strong word, but do you see yourself as less just because you don't have, well, that's one. And second, right, this is the technology. Do you think other people see you different now that you have this?
I think I'm not disabled. I miss a hand, but that's not a disability because I can do technical drawing, I can climb, I can play basketball, I can do everything. The only thing I cannot do is, I don't know, grab objects with this hand because I don't have a grip and I don't have a space to put objects. And I think now people see me different because they know how far I can go with disability. And I think it's a very positive observation from people because it offers me more possibilities in front of the laboral world.
So, and this is just a general comment, and this is something that has evolved through my interactions with Hugh, is there's not such a thing as disabled people, right? That was his comment. There's just disabled technology. The technology hasn't got to that point.
That's right.
But it's a limitation of that technology, not of the body today. So this is just a thought.
When I was younger, maybe 10 years ago, I went to watch the Israeli marathon. And the Israeli marathon is launched in 3 waves. So they have the people that do it for competitive, they go first, and then they have people who do it in like more for fun. But what I had also is a group of people that were on wheelchairs and all kinds of paraplegic competitive that went on their own wave. And one of the guys who was in a wheelchair actually not only won, but he actually passed everyone from the able-bodied competition. So he asked for both medals. He said, I want a medal for able-bodies and disabled. And they didn't give it to him because they realized that at some point there's a down kind of area, and he just released the handbrake and he just went with it. And they said that he doesn't get a medal because he has an unfair advantage because he has a wheelchair. So I think if we start playing with this, we can actually imagine a world where you might have the bionic arm that allows you to lift things that I cannot do, or maybe do things faster than me. And that's kind of the cool stuff when we think about changing the human body. Also, the idea that we have to consider is, like, do we want to live in a world where there's people who have skills that are far above ours? We did it for a while, and now we have the control for that. We can decide if we want this to be the world or not.
Yeah, it's not a question of repairing, it's augmenting, and how far do we augment? There's a question about sports. When you are helping the cyclists, the sports team of cyclists, in sizing them to be perfect, do you think it should be allowed in the Olympics? Because it's an enhancement in a way. They have information that they wouldn't have in other way. Is the Solos glasses for the moment authorized in the regular championships?
Not for competition, but definitely for training. It's a training tool that we used for
would
them.
it be fair to use it on a championship, do you think?
If the regulatory bodies ultimately accept it, it's like the aero bikes, right? Aerodynamic bikes today. If you have enough means to buy the latest, then you have microsecond advantage.
Okay.
So, but this case is the amount of training working together. That's what allowed the team to get there. And this was just a tool to help them reach those peaks of performance and syncing them together. Right? The question is syncing the minds of the cycling
that's
team.
the next step.
Well, that's I think too far beyond. But just there's nothing like hard work, and this is just a tool to help you maintain that.
Okay. A question about why do we connect the brain when in some terms you could connect the nerves? There's a lot of information that goes through the nerves for people that need prosthetics, but why go to the hardest point on the more...
So, I mean, there's kind of an implicit bias here that we all believe that the brain is the CPU, and that's where the source is, so everyone wants to go to the source. But for some solution, I think it's not the brain. So if all you need to do are basic movements, I think that it's really an overkill to go all the way to the brain. If you want to just know, for instance, if you can control your car and make your car go left or right, I wouldn't recommend putting a chip inside your brain that will actually drive the car. You can easily read something from the muscles or the nerves or even the eyes and move the car. If you actually feel that what you need are a variety and a longer and a wider repertoire of options, then usually the brain is the source. And it's partially a bias we have that we want to go to the origin to do things because that's where the signal sits, but it's absolutely not necessary. You're doing a really good job without actually the brain, just by using the nerves, so that's an evidence for that.
And you really think we could one day eat something that would help to connect our minds?
So right now, eating is the way where a lot of the people who are very visible, like Elon Musk, are spending their time. We didn't guarantee this would be the case, but the problem is that if you try to put something in your blood that will get to the brain, there's
barriers.
There's a barrier that don't allow things to go to the brain. So if you can minimize the pill small enough that it will pass the barrier, but then it's usually too small to actually do something. So what we're thinking right now is how can you take multiple pills that will actually independently pass the barrier and then assemble inside your head and attach themselves to a specific location. Didn't work yet. The second best option we have right now is a virus. So viruses do go to the brain. You can actually infect a virus with a device that actually responds to light and allows you to get the brain. The only problem there is that when you get the brain, you can't take it out. So viruses attach to a cell and they're there forever. Okay. So that's kind of where we are. But I think
that stays quite invasive.
It is invasive, but I think that the important thing to understand here is that it's shocking, right? When you hear about someone putting inside the brain a chip or a device, we immediately have a response that's kind of saying, no, this is crazy. But you don't have to go far in the history to see that it actually has an equivalent. If you go back to 1950, that's kind of the first time that people heard about the idea of putting something that's fatty inside their breasts. And everyone was shocked. What do you mean? I'm going to put something in my breast? And now, speed up to 2017 or 18, I think one out of 4 American girls asks when she is 12 to get breast implants as a present. So it's been 70 years that we moved from something that seems crazy to something that is like mainstream. In the same way, I think that we're going to see one guy who's going to seem crazy, who puts a chip inside his or her brain. Everyone's going to tell stories about it. It's going to be a headline in the news. But 70 years later, it's going to be the mainstream. Everyone's going to ask for a chip in their brain when they turn 16 so we can do math much faster or learn languages much faster or navigate without the need for GPS. And it's just a matter of like speeding up and accepting it as society.
Yeah, my last question would go back to David. We started with you. I would like to end with you. What will be your dream prosthetics in the future? In your wildest dreams, once you achieve your studies, that will be probably, I hope, as amazing as what you already achieved. What would be the best prosthetic you would create?
It's difficult to describe because there's so many science fiction films out there. And I think if I speak about the Winter Soldier on Captain America, I think this one is the best prosthetic I can imagine. because it's stronger than a human arm, and it has more speed of movement than my right arm, for example. And well, now we need to search for a material that connects to the brain. I don't know how that works, but it's not that easy speaking. And I think the best prosthetic we can build is the one that enhances our speed, movement, or capacities. And I think in the future there will be people that will break their arm, colloquially, funny speaking, I mean, in order to have and attain a better arm. Yeah.
Okay, thank you very much. I think you deserve a big round of applause. It's the first time you're on stage in your life, and you've been amazing.
Thank you.
And thanks also to Ernesto and Moran. Thank you very much for this great, great show.
Thank you.